What if, out of the silent darkness of space, a black hole suddenly drifted into our solar system? This isn't just a sci-fi fantasy, it's a mind-bending question that pushes the limits of our understanding of the cosmos. Imagine a cosmic monster, invisible and insatiable, making its way toward our home. What would happen to the familiar planets, our sun, and even Earth itself? Let's embark on a journey to the edge of physics to explore this terrifying and fascinating scenario. The consequences would be more catastrophic and bizarre than you could ever imagine. Before we dive into the chaos, let's get a clear picture of what we're dealing with. What exactly is a black hole? Forget the image of a simple cosmic vacuum cleaner. A black hole is a region of space-time where gravity is so incredibly strong that nothing, not even light, can escape. It's formed when a massive star, many times larger than our sun, runs out of fuel and collapses under its own weight. This collapse squeezes an immense amount of mass into an infinitesimally small point called a singularity. Surrounding the singularity is the event horizon, the point of no return. Once you cross this boundary, there's no coming back. It's the ultimate one-way street in the universe. Think of it less as a hole and more as a sphere of influence, an invisible trap set in the fabric of space and time. It doesn't suck things in from across the galaxy. Objects have to wander too close to get caught. But once they do, the laws of physics as we know them begin to break down in spectacular fashion. Now, let's talk about the weapon a black hole wields, its immense gravitational pull. Gravity is the force that keeps our feet on the ground and the planets in orbit around the sun. It's all about mass. The more mass an object has, the stronger its gravitational field. A black hole containing the mass of a giant star compressed into a tiny space has a gravitational pull that's almost beyond comprehension. It's so powerful that it warps the very fabric of space-time around it, like a bowling ball on a trampoline. Anything that strays too close, a planet, a star, a cloud of gas, will be caught in its grip. We've seen this happen in distant galaxies, where stars are stretched and torn apart in a process called spaghettification, as they get too close to a supermassive black hole. The gravitational force on the side of the star, closer to the black hole, is so much stronger than on the far side that it literally gets pulled apart into a long, thin stream of stellar material. This tidal disruption is a brutal display of a black hole's power, a cosmic spectacle of destruction. So, let's place this gravitational monster at the edge of our solar system, say, out past Neptune. The first signs of trouble wouldn't be something we could see. The stellar mass black hole is tiny, perhaps only a few miles across and completely dark. We'd first detect its presence through its gravitational influence. Astronomers would notice that the orbits of the outer planets, Neptune and Uranus, are becoming strange and erratic. They'd start to wobble and deviate from their predictable paths, pulled by a massive, unseen object. As the black hole moved closer, this gravitational chaos would ripple inward. The orbits of Saturn and Jupiter would become unstable. These gas giants, which act as the solar system's gravitational anchors, would be thrown into disarray. Their many moons could be stripped away, sent careening through the solar system like cosmic billiard balls, or flung out into interstellar space entirely. The carefully balanced dance of our solar system, which has been stable for billions of years, would completely unravel. The asteroid belt between Mars and Jupiter could be scattered, sending a deadly shower of asteroids toward the inner planets, including Earth. It would be like a celestial demolition derby, with planets and asteroids on a collision course with one another. As the black hole ventures deeper into our cosmic neighborhood, the situation becomes dire for Earth. What happens next depends on the black hole's trajectory and mass. In one scenario, a near miss could be just as devastating as a direct hit. The black hole's gravity could grab Earth and slingshot it out of its orbit. We could be flung into the cold, dark void of interstellar space, becoming a rogue planet destined to freeze over. Alternatively, we could be pulled into a new, highly elliptical orbit. This would cause extreme climate swings, with unimaginably scorching summers when we're close to the sun and deep, planet-killing ice ages when we swing far away. Life as we know it would be impossible to sustain. The gravitational tug-of-war could also destabilize our moon, either sending it crashing into us or flinging it away, which would have catastrophic effects on our tides and climate. But the worst-case scenario is, of course, a direct encounter. If Earth were to get too close to the black hole, we would cross the event horizon. The process of spaghettification would begin. The immense tidal forces would stretch our planet, our cities, and our bodies into long, thin strands of atoms before we are ultimately consumed by the singularity. It's a truly terrifying end, to be erased from existence by the most powerful force in the universe. Even our sun isn't safe. The black hole could consume it, plunging the solar system into eternal darkness, or it could simply disrupt the sun's internal processes, causing it to flare up violently before it dies. After hearing all of this, you might be looking up at the sky with a little more anxiety. So, what are the actual chances of this happening? Well, you can breathe a sigh of relief. The probability of a rogue black hole entering our solar system is incredibly low. Space is, for lack of a better word, spacious. It's vast, and the distances between celestial objects are almost incomprehensibly large. The nearest known black hole to us is over 1,500 light years away, and it's not heading in our direction. And while it's true that there are likely millions of stellar mass black holes wandering through the Milky Way galaxy, the odds of one of them randomly stumbling into our tiny corner of space are astronomically small. Astronomers are constantly monitoring the sky for moving objects, and an object with the mass of a black hole would be detectable through its gravitational effects long before it posed a threat. So, while it's a fascinating and horrifying thought experiment, it's not something you need to lose sleep over. The universe has plenty of ways to be dangerous, but a surprise visit from a black hole is very, very far down the list of credible threats. Our solar system is, for the most part, a remarkably stable and safe place to be. This journey to the edge of possibility shows us the sheer power and scale of the cosmos. From the beautiful, predictable orbits of our planets to the chaotic, destructive force of a black hole, the universe operates on a level that dwarfs human experience. Exploring these extreme scenarios isn't just about scaring ourselves, it's about appreciating the delicate balance that makes our existence possible. It reminds us that we live on a fragile island in a vast cosmic ocean. The universe is far more powerful than we can truly imagine, filled with wonders and terrors that challenge our understanding and ignite our curiosity. Thank you for watching. If you enjoyed this cosmic journey, don't forget to like, subscribe, and hit the bell for more explorations into the great unknown.